Hello guys, now we are going to see about the experiment 3, that is simulation of push button and LED interface with ARM controller and Proteus. First, what is ARM? ARM is nothing, it is an advanced reduced instruction set computer machine. In short, we tell that advanced RISC machine. Then it is a 32-bit processor. So now, what is the purpose of the code? This program, it is this code. This code, what is the purpose of this? This code reads the state of a push button connected to GPIO pin 13 and controls an LED to GPIO pin 5. So pin 13 and pin 5, these are the pins we used in this experiment. So when the button is pressed, the LED turns on. When the button is released, the LED turns off. So first two lines, that is hashtag include main.h, then hashtag include stdbool.h. So first the hashtag include main.h, it includes the main hall header and stdbool.h for using bool type. Then the button status, this variable stores the current state of the button, that is it's pressed or not. We already seen that when the button is pressed, the LED turns on. When it released, the LED turns off. So the button status stores the current state of the button, it is pressed or not. Then the prototypes, that is the void system clock config, then static void mx gpio init, void push button, then the void error handler. So these prototypes or functions that initialize the system clock, GPIO ports, button handling and error handling respectively. That is GPIO init for GPIO ports, then system clock config for a system clock, then push button for button handling, error handler for error handling, then the main function. So in this all init, it sets up the all hardware abstraction layer. Then system clock config sets up the microcontroller clock source and speed. Then mx gpio init configures GPIO pins for the button input and LED output. An infinite loop. So we use an while loop. It continuously calls push button to read the button and control the LED. Next, push button. So it reads the button status on GPIO pin 13. Since the button is configured with a pull up resistor, the pin reads 0 when pressed. If pressed, sets GPIO pin 5 to high, turning the LED on. If not pressed, it resets GPIO aim pin 5 to low, turning the LED off. I think you guys are clear about it. Next, system clock config. This is the system clock config. It configures the clock to use the internal high speed internal oscillator, sets up clock dividers to run the system at default speeds. If any configuration step fails, it calls error handler, that is any interrupt or any error it come, it calls the error handler to handle the errors. Next, mx gpio init. It enables the GPIO clocks for port A and C. Then set GPIO A pin 5 as a push-pull output pin to control the LED. It sets GPIO pin 13 as an input pin with an internal pull-up resistor to read the button. initially turns the LED off by writing reset to GPIO pin 5. The last one is error handler. So if any hardware initialization error occurs, this function disables interrupts and enters an infinite loop. So we used a while loop in this case to halt the program for debugging. At last, we got the we used a Proteus for the output. So in this we are not connected this, so the LED is off. That is the button is released. Then it is on, so we pressed, so it is connected, so the LED is on. So that's all. Thank you.